So let's find the interval and radius of convergence of this series. Let's go ahead and apply the ratio test. We have the limit as n goes to infinity of the absolute value of x minus 2. We're looking at the n plus 1 term, so n plus 1 over the square root of n plus 1. And then we typically divide that by the nth term, so we will multiply by the reciprocal. So square root of n over x minus 2 to the nth. And if that is less than 1, then we have convergence. So that's what we'll be looking for, the x values that make that less than 1. So let's see what we could do to simplify that. This x minus 2 to the n will cancel with the to the n part here and just leave us an x minus 2. So we're going to bring that out in front of the limit because it doesn't involve n. And we have limit as n goes to infinity of, we won't need the absolute values on this part then, and we'll just go ahead and make a big square root and put both pieces under, and we're interested in when this is less than 1. So we could multiply numerator and denominator by 1 over square root of n, and so that would bring this inside and make this a 1 and this a 1 and this one a 1 over n. And so as we let n go to infinity, this is going to go to 0, so our limit is going to be 1. So we have absolute value of x minus 2 is going to be less than 1, so our radius of convergence is going to be 1. That tells us that right here. So let's go ahead and write this as a compound inequality. So we have negative 1 is less than x minus 2, which is less than 1, adding 2 to both ends. We would have 1 is less than x, which is less than 3. So let's test the endpoints by getting our original series, and first let's put in a 1. So we have, as we're summing up from 1 to infinity, putting a 1 in for x, we have 1 minus 2, so that's going to be negative 1 to the n, and then that's divided by square root of n. Well, this is an alternating series, and since this denominator is going to become large, the terms are going to go to 0. So by the alternating series test, this series does converge, and so we want to include this endpoint of 1. We make this or equal to. Now let's go ahead and try 3. So we're looking at this series from 1 to infinity. We're going to put a 3 in for the x, and that will make that a 1 to the n over square root of n. This one is divergent because it's a p series with the p being 1/2, and we know that if we have p that's not greater than 1, if it's less than or equal to 1, it's going to diverge. And so this diverges. I don't include the 3, so my interval of convergence is from 1 to 3, including 1.